Hello viewers, my name is Taimur Rashid. Today I am going to tell you about the Six Sigma methodology. Many prominent companies like Sony, Toshiba, Boeing adopted Six Sigma process, and as in 2021, I was certificated Six Sigma Black Belt by American Society of Quality. So I hope that I can explain you clearly. Okay. First, I'm going to tell you about the outcome of Six Sigma. The output of Six Sigma is 3.4 defects per million opportunities. It means that if a paper factory adopted Six Sigma process, it will produce only 3.4 defects per million paper production. I am explaining you the term opportunity more elaborately. You think of a pen, there may be 4 type of defects. One defect is in the cap, one defect is in the nib, one defect is in the body, and one defect is in the ink. So 4 type of defects. So if any pen factory produce 250,000 piece pen, and with this 4 type of defects, there are 1 million possibilities of defects. This each possibility of defect is each opportunity. So if any pen factory embraced Six Sigma process, it will produce only 3.4 defect per million opportunity. Now you may have a curiosity about what is the term Six Sigma means. I will explain you in simple statistical terms. Okay. I am showing you a probability density plot. Here, one person took weights of several items and he got these values: 40 kg, 50 kg, 60 kg, 70 kg, 80 kg. And all the y values, we will describe it as percentage, 1%, 2%. So you see, for 50 kg, the y value is 3%. It means that all items measured in 3% case, 50 kg was found. For 60 kg, the y value is 4%. It means that all the items measured in 4% case, 6 kg was found. Similarly, for 70 kg, the y value is 28%. So you can easily understand all the items measured in 28% case, 70 kg was found. This is the concept of probability density plot. Okay. Now I will tell you about some simple statistical term. First, mean means average. Mode is the most frequent number. You see this group of number 5, 3, 7, 9, 8, 5, 4, 5, 8. Here 5 are for 3 times, 8 are 2 times, and other numbers are 1 time. So 5 is mode or most frequent number. You see the median, it is the middle value in ascending or descending order. You see this set of number 2, 2, 3, 4, 6, 7, 8, 8, 9. The numbers are in ascending order, small number to big numbers. Here 6 is the mean, left of 6 phone numbers, left of right of 6 phone number. So 6 is the median or middle value there. Okay. Now I am showing you a probability density plot of normal distribution. Here mean, median or mode are same number. Here 50% of data in this half, you see, and 50% data are in this half. This normal distribution curve is in symmetrical shape. It means the left side and the right side are similar in shape. Okay, I will showing you a non-normal distribution, so you can understand more clearly. This is a non-normal distribution. You see here mean, median, mode are different numbers, and this non-normal distribution curve is a non-symmetrical curve. It means the left side and the right side are not similar in shape. Okay. Now I will tell you why we need mean or average value. You think of a case, you give instruction to a worker that he will cut cables in specific limits. You tell him that the maximum length of the cable will be 6 inches. This maximum length is the upper specific limit. When you also tell him the minimum length of the cable will be 4 inch. This minimum length is called lower specification limit. So you think if the worker makes a target to cut the cable in exactly 6 inch, there is possibility he will cut the cable greater than 6 inch, which is out of limit. On the other hand, if he makes a target to cut the cable in exactly 4 inch, then there is a possibility he will cut the cable less than 4 inch, which is also out of limit. So you can understand that this maximum length and the minimum length should not be his target. So what will be his target? The most safest target, it will be the mean. The average of maximum length and minimum length here 5 inches. It is the safest value to be taken as target. Okay. I am telling you about very simple work, cutting a cable, but for much more complicated work, the keeping the mean will not be easy, like cutting a cable. For example, I can tell you that keeping diameter of a cricket ball. So the factory which produces this cricket ball, their work will be not so easy to keep the diameter in the mean value. Okay. So you see two type of data set. You see in first data set, the numbers are 5.2, 4.9, 6, 5.7, 4.2. In data set 2, the numbers are 6, 7, 3, 4, 6. For this both data set, the mean is 5. You see in this data set 1, the numbers are nearer to mean 5. But the data set 2, the numbers are not that much nearer to mean 5. So this data set 1, they are better than data set 2 because these numbers approaches mean properly. Okay. Now I will tell you about the term sigma, standard deviation. It is a measure of dispersion calculated from mean data and population size, number of data. I will show you the equation. From this equation, you can calculate sigma or standard deviation. Okay. Now please give attention. Here are two curves, 6 sigma curve and 3 sigma curve. For both curve, the mean is this middle dotted number for both curve. So if you make comparison, you see that for this 3 sigma curve, the data are scattered away from the mean. But for the 6 sigma curve, the data are nearer to the mean value. So this 6 sigma curve, we get better data than 3 sigma curve because they are nearer to mean. And as 6 is greater than 3, the higher the sigma level, the data will be better. Now I will describe you Six Sigma curve. In this curve, this is the lower specification limit or minimum length in our case. And in left of this data, these values are lower than the lower limit, so they are all defects. And this is the upper specification limit or maximum length in our case. And the data right of this upper limit, they are greater than the upper value, so they are also out of limit or defects. So you see this left data and this right data, they combine all the defects. So by statistical analysis, it was found that this both data combinedly represents 3.4 defects per million opportunity. So Hope that you can understand the outcome of Six Sigma to this Six Sigma card. Okay. Now I will tell you about some benefits of Six Sigma. The first benefit I am telling in this presentation, that defect reduction, you can understand, and then cost saving, consequent result, because defect is costly. If you reduce cost, reduce defect, cost will be saved, and it is a data driven process. It means that you will talk with your stakeholders in numerical and statistical evidence, not on vague claims. So this Six Sigma, the Six Sigma process is a good and efficient approach to convince your stakeholders. Okay. Now this is the end of my short presentations. If you are interested to know more about Six Sigma, I will make further demonstration for your clarification. Thank you.